when your very first Bitcoin comes to you on your public key,
No, it's something else.
to your address, that's your public key.
Public key and address are different.
Can we get back to the presentation? Yes. Okay. Perfect. Now we were talking about revisiting the whole concept, right? And coming back to what is stored in a block header is, it's the wallet of the miner, it's the root hash, the nonce, and the previous block hash. And then the body has all of the transactions, including the Coinbase transaction. Okay. Moving on, I'm trying to move this presentation. And that is literally how it looks. Plus there's also a block height which determines the number of transactions basically that are there in the body of the block, right? So now Ethereum, look at this guy. If you were somebody,
Future of Ethereum is in his hand.
future of Ethereum is in his hands, and anybody that looks at him will obviously think that's a kid, a very non-serious kid, and I would not give my money to him. But anyways, history about no, I am building a point here, so wait for it, okay? So Vitalik Buterin, born in Russia, 1994, moved to Canada at 6 years of age. In 2011, co-founded Bitcoin magazine. He was an undergrad at University of Waterloo. That's when he co-founded Bitcoin magazine. And as a writer, as a technical writer, he realized Bitcoin's limitations and adding, and these limitations, as we speak, are basically adding new functionalities that requires a hard fork. Now, what do I mean by this? Just to explain it to you is, anything that you want to add as an addition to the Bitcoin blockchain, right? If you want to add a new feature, delete a feature, anything that you want to do requires you to completely do a hard fork. Best example of a hard fork is Bitcoin Cash itself. Completely different cryptocurrency that wanted to basically the same cryptocurrency that wanted to implement completely different principles. They did a hard fork and became Bitcoin Cash. So he realized that, and he proposed a new type of blockchain which was programmable without any hard or soft forks, right? It would work as a world computer, and it was just an idea until it got the name Ethereum. Now, just to let you know, Starknet Foundation is basically the non-profit side of Starkware, which is the research organization behind Starknet blockchain, right? And the founder of Starkware is Eli Ben-Sanson. And in 2013, Vitalik was interviewing Eli for Bitcoin magazine, and for his focus on zero knowledge proofs, right? And I'm going to explain what zero knowledge proofs are, but just to give you a quick backstory, Vitalik invited Eli to invest in Ethereum, but Eli refused to invest in things that he didn't fully understand. That's what he literally quoted. To this day, Eli obviously regrets that decision, but when Eli launched Starkware, Vitalik was the first one to invest along with Naval Ravikant, I think. So he's listed as an angel investor on the Starkware website. So that's a bit about Eli Ben-Sanson. And coming to Ethereum being a programmable language, right? So on Bitcoin, as we see, the protocol is there, the programs are written. Now these are in low, so there are types of languages basically, and let me show you. I think it's here only, yes. As you know already, that computers understand only binary language, right? Zeros and ones. Now above that would be basically a low level bytecode language which can easily which is like an assembly language which can easily be converted into these binary, very easy to communicate with the computer. Initially there was low level languages only. So low level languages like Bitcoin script, EVM bytecode, or even Cairo assembly are all low level languages, and high level languages as we speak in terms of developers and stuff. There's Solidity, Viper, Cairo, Rust, JavaScript, Python, and everything else. Now, Bitcoin is written in Bitcoin script, and the protocol has these programs on. This is a very clear depiction of how the protocols differ. What basically Vitalik wanted to do was, there would be a base protocol on which he wanted more programs, or as we call right now, layer 1s, layer 2s and everything to be built on top of it. It should have been a programmable code that can be compiled and very easily written in a high level language that can then be compiled onto protocol level. That's what his envision, that is what he envisioned. Now, using this world computer and how it works, right? Ethereum, it works as a shared world computer. Now, users pay to execute programs. The amount to pay is proportional to the complexity of your computation as well as the storage that you are using for this computation, right? And the usage of this world computer is measured in terms of gas. Now, what is gas fee and why do we charge gas fee? We are going to look at it. Now, the value of gas obviously depends on the demand, and the more demand, the more gas and the more money spent per transaction cost. Now, my personal opinion, or what I thought initially, was gas is just a fancy term for transaction fees, right? So anytime you make a transaction, we're looking at coming back to the same example, right, where Elvin wants to send BTC to SAT. What happens? He will have to pay a gas fee along with his transaction. Now, what was gas fee? What is gas fee is basically, it's not a fancy term for transaction fee. It's there for a different purpose. We're going to get into it. But the reason it is termed as gas is because it is because when you want to execute a computation on this world computer that we're talking about, it needs to basically burn to get that computation working. That's why it's called gas, because you're burning it. But why does it exist altogether is because of this problem. So, do you know Alan Turing? Everybody? How many of you heard of Alan Turing and what he's famous for?
I remember, but I forgot.
Any
Turing completion or the coding, I know that.
Yeah, so
Turing test is the AI test, right? That they
Like
The
until
concept
Ethereum, I
between
know
human
Turing
and-
complete-
nobody watched the Benedict Cumberbatch movie.
No,
Imitation
I
game.
Why? Yes, correct. Imitation game.
No, I have not. I only know Turing complete, non-complete.
He created like a machine called Enigma.
He broke Enigma.
The Germany's secret.
Yeah.
Now I remember.
So, okay, he's a mathematician, scientist, or whatever you want to call it. Sorry, but there's a very good movie called The Imitation Game, starring Benedict Cumberbatch, who plays Alan Turing, and they show how he breaks Germany's #1, during the World War, the system that they used to transmit messages and signals to their armies, right? So it was called Enigma, and nobody was supposed to break the Enigma, but the Turing machine actually broke the Enigma code, and that's why he's famous for. If you are somebody who's a mathematician, your highest form of recognition is the Turing Award that happens every year. So the award is named after him, so he's that mathematician. But he also came up with, so the halting problem is again something that Alan Turing discovered, where there are two types of programming languages. One is Turing complete and the other is non-Turing complete. Now, the main difference is any programming languages that uses the concept of loops, right? Whether it's for loop, while loop, or do while loop. The concept of loop, any programming language that supports the concept of loop is a Turing complete programming language. Now, a non-Turing complete programming language would be any low-level language that does not support loops. So, Bitcoin script is not a Turing complete. It does not support loops, since it's a scripting language, right? It's a low-level language. Bitcoin script, it's not Turing complete. But the problem with Turing complete languages is it can easily get into an infinite loop. and break the system. Deadlock, that's what we're talking about, right? So since it's prone to fall into infinite loops, that's where DDoS attacks happen. You know what a DDoS attack is, right? Denial of service because of what? Distributed denial of service, because so many multiple, like the hacker attacks through like raising getting the system stuck into an infinite loop of requests that are hitting their network, and then the whole cloud goes down. That's how DDoS attacks happen. So any programming language that supports infinite loop is prone to get hacked by DDoS attack. The reason and Solidity is also a Turing complete. It supports Okay, if a blockchain were to fall into an infinite loop, the whole system would halt, right? You're getting my point? And Ethereum pioneered the notion or the concept of gas only to mitigate this problem. So let's say if I added money to the transaction request that I'm raising, that is what will stop these DDoS attacks, because you are adding like a barrier to it. You are understanding, when you want to raise a request, it's not free anymore. It's there's a barrier to entry. That's the reason the notion of gas was initially introduced, right? And if you measure resources with gas, every low level operation has a cost in gas. And it's just how much resources you are utilizing. So the bigger the computation that you want to execute, the more gas will get burned. This way, this is how they basically prevented the whole Turing complete falling into infinite loops while using Solidity, right? Now, a complex transaction uses more gas. Simple transactions use less gas, but each transaction also must define a gas. Now this is very beautiful, because sometimes what happens is the gas on the network, so depending on the traffic of the network, the gas increases or decreases. So how would you know how much transaction or gas fee is getting charged on your transaction, right? So it defined this beautiful system where you can actually put a gas limit, and if let's say I want to transfer 2 BTC or 2 ETH to you, and my gas limit is 0.1 ETH only, right? If that increases to the limit, the transaction is immediately aborted. And the protocol also defines like a max gas per transaction and per block. This way, it not just prevents infinite loops, but it still exactly can't prevent infinite loops, but it can definitely prevent DDoS attacks, right? Now next up, why is not this going on? Yep. So welcome back to Gavin Wood. If you remember this guy, who is also he's technically currently the most technologically knowledgeable person in the world right now, Gavin Wood, because he actually wrote the first interface of Ethereum as well. And he introduced this concept of Merkle-Patricia trees, derived from Merkle trees, right? So Gavin Wood, co-founder Bitcoin, and then co-founder Ethereum.
Ethereum and Polkadot.
Now then Polkadot also. Okay, he's a tech person. I'll move if you are clicking pictures. He derived the concept of Merkle-Patricia trees, which came out of Merkle trees. Remember we talked about Merkle trees. Now Merkle trees good for integrity checks and proof of inclusion, but they're not good for storage, because it's very slow and it's very huge in size. Okay, and Bitcoin uses a key value like database structure, so not Merkle trees. So how do we get the best and the most efficient storage? That's when Gavin Wood invented something called as Merkle-Patricia tree. I don't know who Patricia is, but it's there in the name. Okay, in 2014. So MPTs basically expand on the concept of MPs as a DB alternative, where root hash, storage proof, efficient storage, fast lookup, everything is handled at its global state, right? And this is how it works basically. So the only problem is, remember the Merkle tree that we looked at, it takes a long time to do that lookup because of going back and forth towards it. Now, how does Merkle-Patricia tree solve it? This is the beauty of it. It basically picks up all of the common characters. Like if you can see, we use 4 wallet addresses there as a sample. Obviously 0x is common. The next 2 letters again common in all of 4 of them, so that becomes an extension node with key part as A7, and then the next node becomes numbers as well as like characters, and then each number, which of them goes on, and that's how it's broken down. Like it's combined into one and then broken down into so this allows for fast lookups where you can look up for not just looking up but for storing as well. This is a very efficient way of storage. Remember we said that Merkle trees were used for proof of inclusion and like lookups, right? But for storages, that's a very inefficient and slow way of looking up. It's a very large database. This way you are efficiently optimizing storage. If you want to use Merkle, if you want to use the format of Merkle trees, right? You use Merkle-Patricia trees. So coming to consensus versus execution. So how does an Ethereum, if this is an Ethereum node, right? The full node, there's 2 parts to it. There's consensus and execution. The consensus layer basically participates in proof of stake, tracks the chain head, Prism, Lighthouse, those are the examples of the consensus layer. Now we did talk about proof of work, remember, and how proof of work algorithm works. Now Ethereum started as proof of work but transitioned to proof of stake, and now we are going to look at what proof of stake algorithm is as well. But yeah, this is how the node looks like. There's a consensus layer and an execution layer. The consensus layer is what participates in the consensus mechanism as well as the tracks where the chain is currently at, right? The most recent node. The execution layer is what executes the transactions and manages the global state. Now, if you, the third one where we are saying the examples of consensus layer is Prism, Lighthouse, TechU, etc. And the examples of execution layer is Get, Nevermind, Nethermind, and Besu, etc. Right? So, now what is Ethereum's proof of stake? So, proof of work, we saw how the protocol required a lot of power and you had to put in a lot of money and stuff, and how the protocol was working. Proof of stake is very simple. Like the word stake means, it's basically the miner has to stake an amount, a certain amount for themselves to qualify as a miner. Okay? So on Ethereum, there is a deposit contract. You stake 32 ETH. And then you will be able to create blocks as well as verify blocks. Now the problem here is, again, you are depending on miners, right? So how do you come up with the how do you figure out if this miner is legit or if they've not done any they're not inculcating false transactions or blocks to the they are not creating any fake transactions or allowing any false blocks, is because it's a distributed network. All the miners in the network have this power. Now their staked money, right, which is 32 ETH, there's something called as slashing, okay, which means that the amount that you staked in the deposit contract can be deducted or can be can be cut off from your account by for 2 reasons. One is when your node goes offline. Okay, but it's a very minute slashing only. If your node goes, let's say the node goes offline, then the 32 ETH is very minutely slashed. But in case you are caught of cheating, then that's when the big slashes happen to that amount, right? So, and you can generate a 3 to 4% annual yield every year, and that is what proof of stake is. Basically, miners that stake their money to create and attest to blocks. Now, major differences between Bitcoin and Ethereum is Bitcoin supports BTC as their cryptocurrency, Ethereum supports ETH. which is programmable currency. Consensus is proof of work. Here it's proof of stake. BTC is programmable. BTC is not programmable because of two reasons: the hard forks that we talked about, plus it's on a low level language. You have to learn Bitcoin script to actually be able to contribute to it. This is programmable, high level language. We talked about it. It's not the end because
It's just a curious question.
yes.
32 ETH on a staking node.
Mm-hmm.
If an ordinary person or someone like us techies decide to get together and do it,
Yeah.
how likely could get hacked?
This thing, the node.
Well, I don't know. I should be asking that to Leo and Peter.
Yeah, I am also not sure. I've never like really. The only time my mind is on Polygon. So.
You mean access to the private key? Because that's the way you can kind of try to take something out of the license.
Like, how would they be hacked? Is my question.
I don't know. We could try this. 32 is not that difficult, right?
It's 112k, I think.
I'm not worried about the amount. I'm just saying I could get 32.
There's like Lido staking
Could build a
also.
node as well.
Liquid staking.
Huh?
There's Lido staking also. So they remove the barrier of the 10 TB.
Because I'm saying 3 to 4% is not bad. It's not in dollar. I know it's a leak, but each value can only continue to go up. And trying to stake anything else, I've seen its headaches. So Bitcoin doesn't have staking. So at least you can showcase.
Yeah. The proof of stake thing that you're talking about, right? In fact, I remember Solana. No.
Solana start with the blockchain itself is 4 terabytes or something, 30 terabytes. I looked
How this staking, I'm not exactly sure how miners become miners on Ethereum, honestly.
Validators.
But
Validators.
Yeah, exactly. Validators become validators on Ethereum, but like if you look at all the other chains, there's either like you getting approved, because ICP had that, you have to be approved to be a ICP validator / miner or whatever you are calling them.
If you stake 32 ETH, like you become a validator.
On
If you don't-
Ethereum, right? Then
That's it.
Then
You
you
make
validate
3-4%.
the transactions, you get the gas fee from there. That's how you get the
So
incentive.
there's a lot
Yeah,
to
but again, so how do you, again, the thing is, the gas fees for computational purposes, right?
yeah.
So, are we calling it a gas fee or transaction fee? But
What are we
you said
calling?
Both are not the same.
So like,
No, the reason that it was introduced, what I was saying is, see, in my personal opinion, it's still a fancy name for transaction fee, and it's so much better than paying it to a protocol than to third parties, where the middleman fees is so much more than any transaction fee, right? Now that's again a very situation specific statement, because during like Bitcoin halving and stuff, the price goes up to like $50 or I don't know, $150 the last time during halving when you wanted to do a transaction.
that happens when the congestion is happening.
Yeah, due to congestion, and congestion is one of the problems. Yeah.
I've paid gas fees up to $3,000 and
Exactly. The
I'm
network
saying-
congestions is it's not scalable.
all I'm saying is that we are very good at Bitcoin right now, and they are okay at Ethereum. One of the best things we could do to showcase Ethereum, and if we get enough people to put it together, and we can get it out without getting hacked.
Ethereum and or Solana, which one?
I'm not touching Solana. I started with a headache. It got so much. 30 every, proof of history, how it works. If I define A, it gets written to the blockchain. Just define something, it gets written to the blockchain. It is a huge blockchain to deal with. And we don't have the bandwidth to start.
You wanted to take a picture of this.
Yeah, I'm just saying, you know what, it's easy to talk, but I don't have that much bandwidth to start with Solana. I'm not doing it. I'm just doing Ethereum because I know what Patricia trees are. Thank you.
Tries. Okay, perfect. Now, talking about Starknet, we already discussed how that's the research part and this is the foundation part. Research part focuses on, it's a for-profit organization, focuses on research and development, and the foundation focuses on education and not-for-profit initiatives, right? We do not really need a recap because we just discussed this, but that's right there with you. If you guys have any questions, let me know. Okay, moving on to scaling Ethereum and congestion, how Alvin and Leo just pointed out. This is the NFTs that I was talking about, CryptoKitties. Yeah, CryptoKitties, they are the first. So here's the thing. At the beginning, Ethereum obviously did not have that much demand. So low demand means cheap gas fees and cheap transactions. In 2017, the first NFT collection, CryptoKitties, launched. It became so popular that it consumed almost 15% of Ethereum altogether, and it triggered a bidding war literally for blocks, the block space. That's my phone? Oh, okay. Okay, sorry.
Did you kill the street?
Huh?
You sure you didn't kill the street?
Yeah, I don't think so. It did not,
Is that
right?
what happened last time?
I don't know.
It's still streaming.
Okay, perfect. Now, it did trigger a bidding war for block space, like I was saying. Now, $3 per transaction. So, gas fees became $3. Now, for us, if we are looking at it because of inflation and currency debasement, like $3 for transaction is just such a normal thing, right? But that's not what we're talking about here. Second wave of NFT collections in 2021 saw $100 per transaction, and Ethereum became so congested that it was literally unusable, and it needed to scale to handle more traffic. It's working, I believe. Okay, perfect. Now, if any of you are into cloud engineering, you would know there are two types of scaling: vertical scaling and horizontal scaling. Two ways that you can do it is either create lots of inexpensive nodes, which becomes highly decentralized, robust and secure, or you can actually increase the, like Alvin was mentioning, the computational power and make these nodes, fewer nodes, more powerful. I wouldn't say it's less secure, but it's less decentralized altogether. So you need a lot of computation power in these very basic machines also for it to be able to run nodes. Now, that's what Solana did. They picked up, they tried resolving this congestion by doing this type of scaling where they increased the amount, like made the nodes more powerful. And what others did, that's what we're going to look at. Okay?
Solana is 400 terabytes just to deal with that blockchain. Make the camera a little higher. We're monitoring it from here. It's not taking the top layer of things.
Okay.
I mean, like the top.
Yeah,
layer.
yeah.
We'll let you know if it's okay. We're watching
Okay.
it from here. Okay, now I think it's okay.
Okay, perfect. So now the major differences that we need to talk about is how Ethereum is the foundational layer and layer 2s and rollups. You guys have heard about layer 2s, you guys have heard about rollups. Can somebody tell me the difference? What's a layer 2 and what's a rollup?
I actually know what layer 2s are, but roll up I came here to learn from you. I'm not kidding.
Okay. Anybody? Okay, what is a layer 2?
Layer 2 are basically things that came into existence to be able to do things better, like the Lightning
Scale
Network,
Ethereum.
like the Bombay Network, what's it called? I keep forgetting.
Polygon.
Polygon.
That's what Mumbai
I
Network.
can't remember it. Matic, okay.
Yeah, and that's what I like. First, I got into mining because of Polygon only. But yeah.
I first heard about Polygon because Ethereum was proof of work still, and Polygon did it much faster. And somebody asked me whether that will really work out in terms of an investment. I looked at it and I saw it was an Indian thing.
Okay.
And they actually called it the Bombay Network. The name
No, their
They have a RPC node, like public RPC.
Yeah, that was the Mumbai one, but that also went down. Half of my projects on my GitHub repository don't work anymore because their testnet went down. Now it's Amora, but that is also not working.
I also noticed that after having paid heavy gas fees, people used to use Polygon only because they could even do their testnet directly on the mainnet. It was that cheap.
Yeah, plus because transactions, I remember because Polygon was actually termed as India's blockchain, right? During the merge is basically when Ethereum moved from proof of work to proof of stake. So during the merge, I remember like tech leads, product managers, and everybody in the tech industry celebrating on the roads, like with like bands and stuff, and like celebrating like it's a festival during the merge.
But where?
In India. I was in India during the merge.
Also big in Hyderabad.
Yes, in Hyderabad. Literally, I could see tech managers dancing on the road just because they like the merge happened, and they were like. So I did not really understand what was happening, and we had this whole huge. No, that's because they were that's what's proof of stake, right? When it moved to proof of stake, why they were celebrating was now transactions would be so much faster than they were on proof of work, right? And because of that, because of the delay in transactions, Polygon was losing a lot of money, and everybody that was in the blockchain space were like so happy about the merge. Like I remember they hosted specific events to celebrate the merge.
I would still think Polygon is very relevant. Even
Irrelevant or relevant?
Polymarket runs on Polygon. Polymarket runs on Polygon.
It's very relevant even after all this merge and everything.
It is, and everybody. I am telling you, right? Especially in India, it was like a festival in its own that got celebrated. So it was really funny to see, and that's what sparked my curiosity.
You remember the guy who came in and we were discussing mining and stuff, and they were investing into proof of work for Ethereum.
It was also
There was
largely
a
a
whole
smooth
bunch of us who still
transition,
thought
right?
that
A very smooth transition, yes.
It was actually
If you think about it technically, right? Exactly. It was a very beautiful transition because they tested it so well that because a lot of times such a huge transition would require like a lot of time and stuff, but it did not. It was a very smooth transition and it was celebrated all around the world. In fact, Twitter also lit up, I think, during the merge. I'm not exactly able to remember, but it was a very grand celebration, at least from where I came from.
This was 2016?
No, 2022 to be precise.
2022?
Yes, 2022
Yeah, Ethereum moved from proof of work
to proof of stake. It was called the merge.
I know of one of the large mining companies where we did a meetup. I was part
Yes.
of the panel. We had a whole discussion about why.
I know exactly because we celebrated it like the whole. So where I live, there's a huge stadium, like not a stadium but a huge what's it called? I'm exact. No, like an atrium, auditorium, or whatever you call, and like anything that plays there plays in my house.
We need a Bitcoin guy at
So.
Because we did. They got that kind of celebration.
Yeah, we did that kind of celebration. So I remember. Anyways, coming back to layer 2s and roll-ups, right? What's the main difference? Now we talked about how Ethereum's congestion was a problem and scalability is required, right? Where did roll-up? What is the difference between a roll-up and a layer 2 is? A roll-up is basically, so Ethereum is its,
They batch the transaction and like put it to layer 1.
Layer 2 also has to do that only.
Yeah, eventually. So does
Everybody
that.
has to. So, okay. So, main thing, or firstly, what layer 2 or rollup does is all the transactions happen on the layer 2, right? Essentially, they happen on layer 2, but they have to be verified on layer 1. Okay, all the rollup, layer, what is a rollup is if the transaction is getting verified on Ethereum as layer 1, then it's a rollup.
Say that again.
If a transaction is, if these transactions that's happening on a second layer, right, on a layer on top, is getting verified on Ethereum as layer 1, then it's a rollup.
What's the purpose of the rollup? I mean the layer.
Because it's cheap.
To scale. congestion to overcome congestion.
So layer 2 is you do your transactions, and once you verify the transaction, you're doing a roll-up.
No. So layer 2 doesn't do a verification like Lightning. Right?
No, they
Layer
can-
thing,
they can-
at
no,
some point you
no.
settle.
Yeah, but when
You're
you
not
sell
settling
it,
every time.
No. When you settle on Ethereum, it's called a roll-up. When you settle on any other blockchain, it's called a layer 2.
so, but eventually,
Yes.
eventually you have to settle on the
On a layer 1, yes, you have to settle on a layer 1.
But then once you settle on a layer 1, then what are you calling it?
A layer 2. So
Layer one
it's
is
very
for
simple. If
verification.
Mhm.
So you can do the computation on layer 2 and submit the transaction to the layer 1.
yeah, if that layer 1 is
So-
Ethereum, it's called a roll-up. If it's any other blockchain like Celestial or like any other blockchain, that's a layer 1. It's called a layer 2.
So let's take Polygon.
Yeah.
Okay. You do 1 million transactions on Polygon.
Yeah.
Every transaction doesn't have to be settled on Ethereum until you.
So here's the thing: a layer 2 can be a roll-up, but a roll-up is not a layer 2. That's what. It's technological jargon to make the industry complicated.
Every time it has to settle.
That's a roll-up. So to me, it's you're just playing with
See.
words.
See, Lightning keeps on going until
See.
you decide.
Until you close it.
So there's a difference. It's the same thing here. Is if you're settling every time it's a roll-up.
Well, but if you're selling every time, you're paying for a transaction fee, right?
No.
You do like 1,000
God,
transactions
no.
on layer 2.
Yes.
Like you deploy a smart contract which do like 1,000 transactions, then you batch the transaction and like put it on layer 1. So you are verifying the transaction on layer 1.
Once.
Yeah.
Guys, can I interrupt? Yes. Okay. If let's say you do 100 transactions on your layer 2, you bundle all of them up, you have to verify these transactions at some point. It cannot keep going, right? You have to verify it on layer 1. The moment that layer 1 is Ethereum, it's a roll-up.
Okay.
The moment that layer 1 is not Ethereum or any other layer 1 blockchain like Celestial or any other layer 1, if you are that uses EVM, right?
So roll-ups are slightly less scalable than layer 2s
How?
because they're still, right? If that's kind of what you're implying, no?
Okay.
Technically, let me be very honest. There's no
It's not a simple
difference.
concept because to me it's like you're looking at it this way. You're saying once I hit the main protocol, I'm a roll-up.
Yes.
But if I stay on layer 2, I'm not a roll-up. But eventually layer 2 has to hit layer 1.
Yeah.
See, every roll-up is a layer 2. Every roll-up is a layer 2. Yes, but every layer 2 is not a roll-up because the only reason you are categorized as a roll-up is when you are rolling back to Ethereum.
So
If you are not rolling back to Ethereum, you are not a
So
roll-up.
as long as you stay in your layer, you don't have to touch the main blockchain.
You have to.
So name me one layer 2 on Ethereum that is not a roll-up.
Like,
Exactly.
I'm just saying.
there's a blockchain that uses Celestial to verify its transactions. I'm not able to. That's why I'm keeping on saying Celestial.
Nathan, quick question. He asked.
So name me one layer 2 on Ethereum that is not a roll-up.
The one that verifies its transaction on Celestial. What's
But
that
if
one called?
that's the definition,
Then why if I don't have to verify my transaction on layer
you know,
1?
we can make
Then-
out
then-
Yeah,
what
yeah.
you are new.
Yeah.
He's ready to fight. I'm getting out of this. I'm done yet. I'm too rich for this. Fuck it. Why am I breaking the head? Okay, I get it. You know your definition is good. I'm not taking it forward.
Yeah.
I wanted to know.
The reason it's called a roll-up is when it's rolling back to Ethereum.
Which
That's
is all
it.
layer 2s on Ethereum except Celestial.
No, there's a blockchain that uses Celestial for its transaction verification.
Let's say Lightning. Lightning is a layer 2, which is a Bitcoin.
Every layer 2 is a roll-up. Every layer 2 is a roll-up.
If it is on.
Sorry, every roll-up is a layer 2. Every layer 2 cannot be a
So
roll-up.
if it is on Ethereum, it's a roll-up.
I'm doing a roll.
For example, Solana started
Going
as a
to
layer
layer
2
one,
and then
that's
now
one
became a
core.
complete
If
its own blockchain.
I stay in layer 2,
That way
it's
even
just a layer 2.
a lot of things start on
You are
Ethereum.
doing-
Yes.
Exactly.
But some of them
Roll-ups,
start-
then becomes layer 2 and then becomes their
Layer
own blockchain.
one, you send the proof to the layer 1.
So I'm not doing any computation on layer 1.
Okay, you
I'm
know
doing
what? I get it.
computation
So
on
the
layer
word
Yeah,
roll up
yeah,
is
yeah,
not
yeah,
that
yeah.
complicated.
It's not that complicated. That's what I've been trying to
Let's just call
explain.
polygon a roll up.
Yeah.
Yes, no, I mean, yes, it is a roll up.
Polygon is a roll up.
No,
We just
no.
didn't know it yet. Just because it got
To me,
defined.
everything is a roll-up.
That
It
everything on
is.
Ethereum
Everything on Ethereum is a roll up.
Yeah, so
And
then-
every roll up is a layer 2.
So today-
But a layer 2 cannot be, every layer 2 is not a roll up.
So
That's what
Lightning
I'm
is not a roll up.
How can you say every layer 2 cannot be a roll-up, but then every
See.
layer,
Lightning is not a roll up. It's not on Ethereum.
but like lightning
It's on
is
Bitcoin. So it's a layer 2 and it's not a roll up. Everything else on Ethereum is a roll up if it's a layer 2. Because it eventually settles on Ethereum.
Yeah, but then if you're going to roll up to layer 2, it doesn't matter which chain it is. If I have a layer 2 on Bitcoin, right, lightning or not, once my transaction hits Bitcoin, it's a roll up.
No, so the word roll up is only on Ethereum. No other blockchain, right?
Okay, well.
Get what she said first.
Okay.
As your
Okay, so
sacrosanct.
Okay, funniest
then-
crowd
okay,
till
so,
date.
okay, so then we're saying that layer 2, because with Bitcoin you have a layer 2, in other protocols you have layer 2.
They are not roll ups. It's
Okay.
only Ethereum.
So Ethereum considers this transaction, anytime you verify on layer 1, it's a roll up.
Yeah.
Bitcoin, when you verify on layer 1, is not a roll up.
Because it's not.
No, not on layer 1, on Ethereum specifically.
Okay, so this, we're just talking Ethereum or not any
Yes.
other blockchain.
You know what?
The moment it becomes any other blockchain, it's a layer.
Zcash came in or ZK, whatever came in, we were out of the whole thing. Now because a younger person is teaching an older person, you shouldn't feel bad.
Okay, anyways, so roll-ups, layer 2s, whether it's Arbitrum, Optimism, or I don't know what logo that is.
CK sync.
Oh yes, they all have their own like sequencers, right? Now even Starknet is a layer 2. Okay.
And a roller.
No,
It's
it's
not
not
a
a roll up anymore. I'll tell you.
Oh,
why.
they moved out?
Yeah. So it's basically a ZK roll up actually. I'll tell you how. The only reason is it uses CVM, Cairo Virtual Machine. Now they changed their virtual machine because for you to become you usually
It's a roll up, right?
yeah, it's a ZK roll up. It's a ZK roll up. Let me clarify. They changed their EVM to CVM, which uses Cairo virtual, which is Cairo. I will tell you why they did that, and let's look at their pros and cons, and we'll stop the roll up versus layer 2. My worst question ever. Pros.
It's okay. We learned
The pros are it's high performance. Ethereum's it helps with Ethereum scalability. The only cons is the centralization and fragmentation part, because we're fragmenting it into so many different sequencers. There's so many layers, right? Let me show you the difference between how we are looking at this. Block space and block space. Now, what is block space? Block space is, obviously we looked at blocks and what a block space stored, right? What is a blob space? It was introduced in 2024, created for rollups that anyone can use, okay? And I will just move this a
the
little.
only block space one I know is ordinals.
Blob space.
Block space.
Okay.
Are ordinals and digital and light kind ordinals and stuff, right?
Uh-huh.
Where else would you do block space?
That's what we're going to learn here.
Sorry.
Yes.
Interesting. And then block space is a new term.
Yeah, it was introduced last year in March, and it was created for rollups for anybody to use. The goal is not storage with blob space, right? No, I'm just moving it so that you can see that part.
No,
I'll fix it again.
No, your video is still.
I know. I'm moving it for that. So the goal is not storage. Okay, block space's goal is permanent storage. Blob space is temporary 30-day storage only. 30.
RAM versus ROM.
Huh?
RAM, ROM.
Yes, correct. So third parties can act as middle people and like store the blob space for a longer time than 30 days, but it's originally 30 days. max of 9 blobs per block, and max bandwidth is 100 kbps. Okay,
What we use block space for?
I will show you. So basically what happens is, wait, not here, here only. All of the transactions, the data of the transactions gets stored on block space, right? And this blocks only essential information that needs to be verified on, that gets verified on, that needs to be like verified and validated on the layer 1, comes and gets stored in block space. This is permanent, this is only temporary, because each transaction has all of this metadata and everything, right? That does not need to be stored. I'm talking about when they're coming to just get validated from layer 2s. And that's what we're going to look at when we're discussing about optimistic versus ZK rollups, right? So rollups are of two types: optimistic rollups and ZK rollups. Initially, ZK rollups were just a myth, and optimistic rollups were the types of rollups that existed. Now, what does optimistic rollups actually mean? In this, what we are assuming is the layer 2 sequencer, right? What we're the machines that we saw on the top, the layer 1 was Ethereum, the machines on the top, they are called as sequencers, okay? So in optimistic rollups, what we believe is that the sequencer is honest until proven guilty. Right, and but in ZK rollups, every single time the sequencer's honesty is verified. Okay, it's not, we are not assuming innocent until proven guilty anymore. Okay, in terms of security, this one uses fraud proofs, this one uses validity proofs. We'll get into them. The L1 finality for optimistic rollups is 1 week, while for ZK rollups is only a couple of hours. I will tell you why that differences exist. In terms of block space, what do you store in block space, right? And that was your question. What was stored in block space versus block space? In block space, they store the state routes, L1, L2 messages that's going around, the commitments that are going to be stored in blobs, right? And then either fraud proofs or validity proofs, depending on the type of rollup. In terms of block space, they're used to, in optimistic rollups, they're used to store the transaction details. In fact, they were initially formed only to store those large transaction details, but in ZK rollups, only the state differences is stored in those block spaces, in case you want to reverse back, right? And let me show you how this works. Talking about ZK rollups, I told you it was a myth before, and initially only optimistic rollups existed, right? What is zero knowledge? Can somebody tell me what is zero knowledge proof or zero knowledge?
I'm out. I'm like, no. Now you've reached my. That's why I came.
Okay.
That's why I was.
What do you think is zero knowledge?
In broad stroke concept, the ability to validate someone's existence or proof with the minimum amount of shareable information.
Do we have like a board and a marker? I would love
Yeah,
it.
I have.
Or a pen and a marker. I'll just do
I
it.
have one to carry the board.
Okay.
You know?
No, because I have this perfect example from grade
Here's the
12
board,
again
right at the back.
that I can explain to you. No, that's a very big board.
You
It's
have
very
my
small.
smaller one from the older days when I used to train. I used to train George at.
Damn, okay.
They used to all come. I used to repeat the whole blockchain basic lesson at Pearl King, 2016, 17. So you have a nice smaller one.
Oh, thank you. That's all I need.
Just keep it right there so you can see visible.
You have an eraser over there
Okay.
I don't know where it is.
on the chair.
I just need a marker.
Don't.
It says Dogecoin.
Whereas when we were doing something like that. Yeah. And then a marker.
Thank you.
Check over there.
Yeah, I see.
Okay, this is permanent marker, people.
Go with all
No,
the-
I don't.
all of them, and none of them does-
Yeah, it is permanent marker. I have perfume though.
Dry erase.
There's a whole bunch.
Look, read them first
Can
before.
use water.
Dry erase.
What is dry erase?
Dry erase means it's not permanent.
Okay, just check one.
Tika,
Yep.
you take the last two tidbits.
Yeah, go ahead.
No, you take it, please.
Go ahead.
You earned it.
So we have some dry erase here, but I don't know if they're so good, but.
Okay, guys, you're gonna smell a lot of perfume, but I'm doing it for
Oh,
you.
if you want a water cleaner, I have. Here.
Yeah, this is not going because it's permanent.
It should be permanent.
Oh, yeah.
Yeah, it's not
Okay.
You are surprised? I don't know Malayalam.
No, only thing I know Malayalam is
Malayalam, Sulu, Kannada, Konkani, and Hindi. So they live
You
in
can kind of also use this.
So it's in north, south,
Oh, thank you.
Indian, So 5 languages everyone.
So, the reason I asked for a board and a marker. And where is that marker?
That's
That's so common. There's so many people in India. Like, in big
Polyglot.
cities.
They call it polyglot.
Is this. Again, full credit to my grade 12 teacher for explaining this.
What was the name?
Exactly. That would be giving her credit.
Tilaga.
What is it?
You just,
Tilaga.
you actually just referenced her.
No, doesn't she was in Saudi. No?
Yeah, her
And
name
she
was
would be in a
Tilaga.
girls' school where the teacher had to be a female. Right?
Yes,
I'm
yes,
just
yes,
saying,
yes.
I wasn't expecting a man's name.
Yes, her name was Tilaga and
You
she
have to
was
be
my
able to
computer
nail
science
this the
teacher.
moment she said I wasn't educated in Hyderabad. I've spoken to her when we had a long
Okay, guys, I need 2 volunteers. We'll take
Okay, there's Nitin. I wasn't told him, Leo.
Nitin
Yes.
and Leo.
I'm
Okay. Leo says, so here's the thing, okay? Now, just to let you all know, this is a reference to the Alibaba and the 40 Thieves kind of story. But this is like a cave, and then there is a secret door here that has a key, okay? Now, Leo tells Nitin that I have the key to this door. But the moment Leo would show the key to Nitin, Nitin would immediately copy it. Right. So instead of showing the key to Nitin, what would Leo do? Leo would just enter from here, go all the way, unlock the door using his key and come out from here, which would prove to Nitin that he has the key to this door. That's basically a zero knowledge proof, where you have zero knowledge what the key is, what the source, like what are we talking about in terms of like hiding, right? What is the actual information here, and you are able to prove that you have that information, right? You're getting my point? So very simple example, how do we prove that he has the key if he's able to go through the door and come out from the other? That's very broken down to the minute level, zero knowledge. Okay, and that's how Nitin, that's how Leo is proving to Nitin using zero knowledge proof. That's literally in its core fundamental form. Okay, now how did the evolution? This is Charles Hoskinson, and can somebody tell me who he is?
He was also on the Ethereum along with.
Correct. The founder of Cardano, yes.
Wait,
Okay. Sorry.
Before Cardano, they were all on the same team when they went
Yes.
to start Ethereum.
Yes.
Hoskinson, Wood, Vitalik, all
Yes.
the OGs,
Yes.
and we were like, who are you?
Exactly. So Charles Hoskinson in 2020 about ZK Rollup said that Starknet is dumping a bunch of money into Starks, which is the ZK proof. An academic concept that is going to require a tsunami, a ton of research to get into a practical contract. It's going to require years and years and years of hard work to get to a point that these things are practical. So everything that Starknet was doing, Charles Hoskinson said, is just theory and research and cannot be implemented in the real world. If somebody says that to you, it hurts you. And then you launch it in a year. So Starknet launched the, it's here, I thought it was on the other side. So, and he said
What do you
basically,
mean by stocks? Oh, it's the token?
no, it's the ZK proof.
Also, the word stocks is ZK proof.
I will get
Okay,
into
sorry.
it. Yes.
This
Different
said
versions
dumped a
of
bunch
ZK
of money into stocks.
Yes. There's different versions of ZK, and I'm going to talk about those.
I wasn't expecting this of Australia. He's a decent chap. He just
No, he said no, and he's very. I mean, given the amount of research that he has done, even for Cardano as well, right? So it must have been, like I said, ZK rollups were a myth before Starkware came into the picture and was like, I'll implement it. Charles Hoskinson said that it would take 5 to 10 years to probably get to a practical concept of a ZK rollup. Starkware launched Starknet mainnet in 2021, just a year after he said this. So, what is how do we verify ZK proof, or how are we talking? Because remember, we said validity proofs instead of like fraud proofs. So it requires us to validate the transaction, which means we need verifiable computation. Now, how does verifiable computation work? Favorite problem, it's called the space exploration problem. We are a scientist, we need to go to Mars, okay? But we do not have the equipment, okay? So we come up with this, we engineer and create algorithms that we can to go to Mars, but we do not have the machine or the supercomputer power that we need to basically technically go there. So what do? We ask a rival country who has it to help us, okay? It needs a supercomputer, only one rival country has one. So what do? We send our algorithm to them to run it through their supercomputer, to execute it through their supercomputer and share the result with us. This result, we're uploading it into our rocket and sending it to Mars. Now there's two problems here. One is there's obviously the issue of sabotaging because it's a rival country. The next is a supercomputer malfunctioning on its own. How do we know the result that was given to us from the supercomputer is legit or is the right result? Like I said, we have two doubts right now, right? Whether there was some sabotaging involved or the supercomputer had malfunctioned, okay? Now, when we wrote those algorithms in Rust, if you remember. Cairo programming language is derived from Rust only. But the beauty of the programming language is it gives you a proof with the result. Okay? So now and the beauty is that this proof can be validated on a normal computer. So when your program is put through this supercomputer and executed, it generates the result with a proof. And you can run this proof on your computer and validate whether this is the right output or something was changed in it, literally. So that is why if the execution is intentionally or unintentionally modified, the proof will immediately become invalid. And a regular computer is able to keep a supercomputer honest, right? Again, Cairo's features enables verifiable computation. It runs on top of Cairo virtual machine. Its syntax, like I said, inspired by Rust, similar ownership model. It's a strongly typed language with traits and macros and can be used outside of Starknet. It's not specific to Starknet, and you do not need to know ZK to use Cairo, basically. Right, and I wanted to show you all this demo. But before we move on to the demo, something that I wanted to talk about was, I don't know if Alvin or Nitin mentioned it, that there are types of ZK rollups, right?
Not
so
me. 100% must have been. मैं तो rollup पहली बार समझा है. सुना बहुत है.
ZK rollups, yeah, version. So those versions or whatever you call it, there are different types. So the moment, in fact, Vitalik categorized it. I will just explain it here.
Does Starknet have a token?
Yes,
Yeah.
it's called STRK.
I guess that was Starknet.
No. Star
STRK.
I guess.
It's not. I mean, it does well on days.
That's what we used to say about Ethereum and Bitcoin.
Yeah, but I'm more interested in the technology than the token. But yes. Wait. Okay. So ZK EVM 1 and then ZK EVM 2. ZK EVM 3. And this goes all the way up to ZK EVM. Oh no, it only goes up to 4, I think. Yeah. So this is Vitalik's version of what the different types of ZK rollups, right? What he classified them into 4. The first one is it's the same as Ethereum virtual machine, but it uses everything. There's not much differences, very slight differences in that rollup. Okay, that's called as ZK EVM 1 rollup. Okay, and the more changes that you do, the number here that we're looking at, right? 1, 2, 3, 4. That's when it increases. The more the most changes is when the virtual machine itself changes, like how it happened in the case of Cairo, right? So it's Cairo virtual machine. It's not using EVM anymore. That's when it's a ZK EVM 4 rollup. That's basically what a ZK EVM rollup categories are.
But okay, so these EVMs are ZKs are sitting on Ethereum, right?
Huh?
They're sitting on Ethereum as the
Yes, but it requires a completely different programming language, and like in fact, if you see, Starknet is a ZK EVM rollup, right? It requires Cairo, and it's using like Cairo virtual machine instead of like.
So the whole
Like
purpose of having Ethereum going to whatever it did with proof of stake and expectations to have more speed. Then we are doing ZKs only for zero knowledge, or
Yes.
that's it. That's
Yes.
all that it brings down.
Now, so when we talked about, remember we talked about
privacy aspect also.
Yeah.
privacy aspect also. Plus, here's the thing. Wait, let me show you this part where any rollup, where layer 2s were happening and rollups, right? We're talking about optimistic versus ZK rollups. Before, like I said, ZK rollups, a myth, and optimistic rollups were the only option. Now, even optimistic rollups want to become ZK rollups because fraud proof is very complex to actually achieve. Like the sequencer is literally assumed, like the layer 2, whatever transactions it's sending for validation on layer 1, they are assumed to be true until proven false. When it's happening on a ZK rollup, they have to send a proof along with it, right, that these transactions are valid. And that's why the L1 finality, can you see the major difference is the L1 finality? This is only a few hours, and that's a full week because they have to validate the entire sequencer, right? In terms of even using the blob space, all the transaction details, all the last transaction details are stored because you have to achieve fraud proof out of those. Right, here only state differences are stored. The previous state was this, and now the next state we are achieving this.
Okay, so here's a little bit of a pivot question.
Okay.
You remember when we started this discussion, we talked about using blockchain for supply chain, identity.
Yes.
Give me one example of why we would use ZK in real life.
Healthcare.
Pardon?
Healthcare.
So in healthcare, how? Say, I just want to understand. I'm telling you, I don't understand.
Okay, I'll do a better way.
Okay.
Buying alcohol at liquor store for ID check.
Okay.
So I don't need to provide you my ID.
Yeah, digital identity.
Just all the clerk, the store guy needs to know is that I can buy, I'm of legal age to buy cigarettes or whatever.
Right.
Or alcohol.
So my age is needed by it, not my remaining details.
Not my
Yes.
address,
So
Not
then
even
how-
your age, just verifying whether you are above 18 or not,
That's
or
all.
above
my
21
ID
or not.
is, let's say, somewhere on the blockchain,
Yeah.
but or on Z
Somewhere.
inside ZK5 inside. But I
ZK4.
have a way of sending him only my age to verify.
No, you don't have to send your age also.
Yeah.
And
They
they-
just.
It's the
because of
same
this,
as how I said, right? Nitin and Leo are standing, and if Leo wants to verify he's older than 18 but does not have to say his age also. That validity proof will show that he is above 18.
He was about to go to the cave, right?
Yeah, that cave is your.
Yeah, that was very good.
Thank you.
The thing about that, and I used that example before,
Mhm.
is women go to a lot of bars and clubs,
Yeah.
right?
Yes.
And what happens is, I used to work the door, they give you the ID. Right now, a security person that basically is not of right mind, that ID gives the guy all the woman's information.
All the details.
Phone number.
Not phone.
Not phone number, but address.
Address
Yeah.
and stuff like that.
That's the security issue.
So, best scenario is when you go, there's ways you can do it. I mean, a guy can take a picture of the face, use a camera, and then validate based on some information, yes or no. That's all a person needs to know.
That's right.
We give a lot more information than we need to give to a lot of places.
I think this is like the biggest concept in like the whole space. I think this is actually the biggest like transformative use case for crypto over the next that's why the architecture of this is pretty interesting and cool to understand. So you're saying that if a Cairo virtual machine is used, you don't actually need to, you kind of, maybe I'm making these words.
I'm
up,
going
but
to
you
show
don't
that demo
actually
to
need to do the zero knowledge architecture.
No, and because of that, you know what happens is the scaling problem. The first thing, why did we start doing rollups or layer 2s? Because of Ethereum's scaling problem, right? How is Cairo tackling that? And I will get back to the live demo. Please remind me. But a lot of times this happens is where people want to understand what's happening, right? Now, when block producer produces a block, right? Any block producer produces a block and says that this is the block. All the validators have to verify the entire block. With Cairo, it's executed there, but validators only have to validate the proof. That's if we're looking at this in terms of mathematical terms, if it takes a validator to validate the entire block and that is X, then this time is log X. You're getting my point? Like if
Subset.
very smaller subset of base 2, that's like if X is 10, then the validator would be 1. You're getting my point?
I see.
That's how we're reducing the scaling problem. I'll just get back to the demo where I can show you.
So one more question.
Yes.
Just as you said, this is one way of solving it. There are other blockchains that go with this kind of validators having different, I don't remember what they are called.
That's optimistic rollups that we're talking about. Unless and until they're ZK, then that's when they come to the. It's not just Starknet. What I'm trying to say is Starknet is not the only ZK rollup in this world. There's more ZK rollups, but Starknet is a ZK EVM 4 rollup where it has done the most changes and achieved this in just a year. There's more rollups.
And currently Starknet is still a layer 2 on Ethereum also.
Yeah.
Okay, just saying. It's a rollup, of course.
No, it's a ZK EVM rollup. It has its own. No, it has its own programming language now. It's transitioned to Cairo. Yeah.
I thought Cairo was a.
It's in Egypt. It's a place in Egypt. Yes, it's
No,
named after.
I'm not talking about Cairo. I thought Cairo was a fork of Ethereum. No? Oh, it's a programming.
It's a programming
It's
language.
not an EVM.
No, it's on CVM.
Cairo
Because
virtual-
yes, Cairo virtual machine. Because the beauty here is we have assembly language in Cairo also. It's called Cairo assembly. So you have a high level programming language which is Cairo, okay, and then a low level programming language Cairo assembly. Which so the compatibility is like the Apple ecosystem. Because
and it all works on Cairo EVM.
yes, it all works on Cairo because you are making all of the hardware and the software. Everything works pretty smoothly.
But then all that sits on
What
Ethereum AVM.
No, on Cairo virtual machine, which is like a
but the
rolled.
Cairo is it's layer above Ethereum.
What do you mean layer above
Wait.
Ethereum?
It's not its own blockchain per se, independent. If Ethereum goes down, right?
Yeah, everything goes down. That way.
Right?
Yeah.
Right? So that's what I'm trying to say is that I have a Cairo on an EVM.
Right.
It's-
Okay,
No.
You can still do transactions on layer 2, but like in the end you need to put those transactions in layer 1.
Correct.
Yeah, and if
So if
Ethereum
layer
is
one
not
is
the
wrong.
layer 1, Celestial can be
Yeah,
or
but-
any other blockchain can be.
Ethereum has EVM, layer 1 de facto.
Tell me what happened with Solana.
Solana went down and keeps going down.
400 terabytes here. Who's going to touch it again?
Yeah.
Not me. Okay. After you finish, I have a question.
Okay, so I have this, and it has its own EVM, but it sits on top of Ethereum, right? It works without Ethereum, it's not working, right?
Yeah, you can do.
I mean, you can still
Computation.
do
You
transactions.
can do computation on.
Yeah, I know Ethereum works. I know Ethereum is working. Let's say Ethereum goes down,
Okay.
right?
This doesn't go down because it became a layer 2 already.
Yeah, and then you can come back when Ethereum comes back.
That's what I mean. So
No, you don't have to go down when Ethereum goes down, is what I'm trying to say.
You can keep
so
lingering in the
It's
universe.
not okay. See, that's why I explained this part. If it is whether it's a ZK EVM 1, 2, 3, 4, which means it started with EVM, started doing changes to EVM, and then reached a point where the changes are so much that it's not EVM anymore.
okay, so but then does it have to at some point is a roll up
Okay.
write the transactions to or write something to the layer 1?
When you're ready,
Starknet
Ethereum
is
comes back
the-
up, right?
Huh?
When Ethereum comes back up, if it goes
No, but from what I'm understanding, it doesn't have to. It's its own blockchain.
That's
Yes, sir.
It's been inside Lightning forever.
Layer 2, like you do all the transactions, then you batch those transactions and send it as a one transaction on layer
Correct.
1.
Yeah.
So that transaction is.
That's a pointer. That's your pointer.
Yeah.
Okay.
So if layer 1 goes down, it won't go there.
Uh-huh.
So when it comes back, you can
Or
use it.
just do another pointer and says my checkpoint is here. Last I pointed to there is there. So my delta, my difference is I create a new pointer.
You are not.
Yes.
Why do you
See,
create it?
Starknet is a layer 2, okay? And it's still verifying its transactions on Ethereum. Still verifying its transactions on Ethereum. And we
Okay.
will look at it how it's verifying even though it uses Cairo virtual machine.
So let me
Yeah.
do it this way. I'm on the subway.
Okay.
Right.
You're on the subway?
Long train.
Okay.
I'm on the subway. I'm
Okay.
in cart 1.
Okay.
Right.
Okay.
I can do whatever in cart 1, but if the train stops moving, it doesn't matter.
No, but that's a wrong one. Analogy.
What?
Anyway, I get locked up.
What?
It will start running again, right?
Well, yeah, but
Some
once it
point.
starts running again, once it starts running, then I can still continue doing what I'm doing. Once it starts running, that doesn't negate what I was doing in that section of the train. That's what I'm trying to say, right?
So think of it this way: you're in a train in the subway, and inside that inner train, you can continue doing shit till the other train starts moving.
Guys,
I have a question.
1 minute.
Yeah.
I will just answer his question. I understood. The only thing he wants to know is if Ethereum goes down, will Starknet go down or not?
Yes.
That's it, right?
No, it won't.
Yes, it would.
Eventually. Okay, go on.
It's the ZK EVM roll up.
Okay, so
See,
Yeah.
literally, I don't know why we went into subways and whatever we
So
went into.
assuming we are on a ZK EVM rollup
Yes.
4, that's the latest.
Yes. No, it's not a versioning.
Whatever. If we are using Starknet, we are using rollup, we are doing whatever we are doing in there with zero knowledge proofs, etc. And the token is Stark.
STRK.
STRK. We are in here. Okay, we are working now. It's like we would be working on that polygon. Okay. Questions. Is it proof of stake inside there with nodes and stuff? Just like
Yeah.
yes. How many Stark per node do we? Is there an answer like 32 for every?
Oh, I don't know.
Okay.
For mining, you're asking, right?
Yeah, from a
Like for a
POS.
validator.
Validator.
Yeah, I am not sure.
But conceptually, it's the same as POS
Yes.
there.
Yes,
POS
yes.
here, Stark inside.
See,
So
yes,
train
yes.
inside train.
No trains, please. I did not understand the subway analogy.
So then, let me ask you this. So, the same Ethereum validator is validating those Starknet, or is it a different validator?
No, it is Ethereum only. Listen. If it's EVM, it has to be Ethereum. That's the whole reason we got into the layer 2 versus roll-up battle.
Okay, but CVM, who's validating the CVM transaction?
That's on Starknet.
Okay.
See,
So
individually.
I can be a Starknet validator.
Yes.
Yes.
Okay.
Yes.
Or I can be an EVM validator.
You can be directly an EVM validator altogether, right? You can
Okay.
directly be an EVM validator and still validate because see, oh god, see.
But
Okay.
if I'm an EVM validator with my 32 Ethereum,
You are
and some-
validating Ethereum's
Oh,
this thing.
Yeah, but Starknet validators are getting the rewards there. Those rewards don't come to me in the Ethereum validation of things.
No.
Right?
No.
Correct, okay.
I'm saying I don't get Stark token as rewards. I have to be into that. And that's how the blockchains work, Leo. If you're doing Polygon, you're doing Matic, you get Matic rewards. You're not going to get Ethereum rewards.
See, wait. Okay. Let's just rewind, take a quick pause, and let me explain to you again. Remember why we talked about rollups and layer 2s? Rollup means it has to reach L1 finality. What does L1 finality means?
Agreed.
On layer 2, whatever transactions are happening, whether I am sending to Sat is sending to Alvin, all of these happen on layer 2 because Ethereum has congestion on it. The moment so many transactions what I mean to say is whenever the network gets crowded, that's when transactions, that's when the price of transaction or what we are calling as gas fee increases, right? Ethereum is not scalable. Every rollup or layer 2 is to tackle this scaling problem and then achieve something with it, right? So Starknet is focusing on ZK. It's a rollup. Rollup means it has to reach L1 finality of all these transactions that's happening on Starknet on Ethereum. If Ethereum goes down, Starknet will eventually go down.
Eventually.
Because no, the
Yeah,
chain will
but-
have to stop, right? Because you cannot reach L1 finality
No,
only.
so I was saying if Ethereum goes down temporarily.
What do you mean
Just
temporarily?
say for how Solana keeps going down for 2 hours or something. And then comes back. So I'm saying you're right. If Ethereum
Yes.
goes down, eventually
Starknet will
all
also go down.
all
Yes,
rollups will-
Starknet will also go down. Right. It's still so. In terms of validators that you asked, right? I just googled and it's showing me 20,000 Stark to become a Starknet validator.
Exactly.
Validator
So-
on CVM, right? To become a validator on CVM. Now, when you become a validator on Starknet, you are validating all of the transactions on Starknet
Starknet
only,
Okay.
right? And when these Starknet transactions want to reach L1 finality and they come as like in a yes in one transaction, right? This gets validated by Ethereum or EVM validators,
I don't know how it goes. Anyway, that's something I'll do.
right? And we are going to talk about how it goes through, right?
From Starknet.
Yes, and what they're trying to achieve right now, and what they want to do basically. So again, coming back to our beautiful
Okay,
presentation,
sequence of-
execution versus verification. We saw the differences in the time, right? How much time it is taking. Now, if you move this, wait, what? Okay. Yeah. Now, validity proof to a computation is the same as zip to a file size. How let's say you have a folder and then you zip it, how you are compressing it, right? That's literally what's happening with a validity proof. Your computation is compressed into a proof that can be easily verified and does not require that much time also. Now, what is a validity proof? It's a use case of zero knowledge. The concept is this, the one that we talked about, right? Validity proofs are a use case of zero knowledge concept, right? It convinces the verifier on L1 of new L2 state without sharing any transaction details. Remember we talked about state differences and not transaction details in blob space during the comparison. That's what happens. You're not sharing any transaction details. You're only going to share the validity proof of those transactions being legitimately executed, right? It does not make L2 transactions private, but it does make verification more efficient. So validity proof makes it a validity rollup. It's based on Starks and not Snarks. Okay, now what's the difference between Starks and Snarks, you might ask. Now this concept is again ZK based. Now Snarks, some ZK rollups use Snarks, but Starknet uses Starks, and we're going to see why. Efficient, so basically the validity proofs increases efficiency, improving and verification,
Would
right?
it be right to say the word Starks came out because of Starknet?
No.
Because I remember Snark. It was there ZK Snark first. Right?
Yeah.
That was our life. And now we are using this word Stark so often. I'm like, okay.
That's because Starknet
Nah,
obviously.
मैं busy था ना हम बुढ़े हो गए थे
Okay. Here's the differences, if you can see them.
Oh Jesus! Oh, Stark is quantum.
Yup.
That's it.
It's
Ethereum
beaut. What?
No, I said if Ethereum reaches quantum, anyway, that's good.
Anyways, the differences between Stark and Snark, verification there takes log 2 of n, okay? And here it is constant, it's a constant time that is determined by the specific ruler, okay? The proof size, how much does the validity proof? It's only 400 KB, here it's 288 bytes. Proving time, only 1x, here it's 10x. Trusted setup, you do not. Now what does trusted setup means? You do not require a trusted setup. Like our example of that scientist where they sent their code to get the result to a different, the whole reason that there was a rival country is because you do not trust the rival country, right? But you are still sending them because they have that setup available with them. So you do not need a trusted setup to run Starks, but you need one for Snarks, okay? Starks are quantum secure, by the way, but Snarks aren't. So
I think we are clear. We learned something. Thanks. No, anyone who's not clear, please. I can.
I am more. Yeah, exactly. Now, why Cairo? Now, most people have this question: ki why Cairo VM and why not just EVM altogether, right? The reason is this. Compatibility. Now, obviously, ZK EVMs they use Ethereum virtual machine because of compatibility. The reason Starknet decided to move to Cairo VM is because of performance. How we're looking at the difference in performances, right? In fact, L1 finality, I said a few hours, right? With validity proofs or ZK rollups. With Starknet, it was currently, I don't think it's even 5 hours. It's less than 5 hours now because
back one, please?
Yes.
I just need a picture.
This one?
Thank you.
You're welcome.
Okay. Done. Thank you.
Okay, so with Starknet, right? Because this presentation came, we made this presentation before the recent update. So the pre-conf is not even half a second now. It's less than that, and L1 finality is achieved within like I think an hour or two only. I'm not sure. Don't hold me accountable for it, but I know it's less than 5 hours now. Okay. Now, if you're executing your transactions on Ethereum, obviously it's 6 minutes because it's layer 1 itself. If you're executing it on optimistic rollups, it's 1 week altogether. In ZK rollups, the times varies, but for Starknet, it's so fast. Now, Starknet is also powerful of doing almost 1000 transactions per second on the mainnet. And the transactions are super cheap. Verify it by yourself. You can even go ahead and look at all of these transactions. The last time the transaction cost was 0.0005 dollars. So yeah. So why Starknet? Because they optimized the ZK tech. They increased computing power and reduced gas fees. They are secured by Starks and reaches N1 finality on Ethereum. And they're a powerful program. They use a powerful programming language, battle tested tech stack for 4 years, with 1.5 trillion in transactions, and I think withdrawn assets to L1 in almost 5 hours, and they don't require any trusted setup.
What do you mean by in 5 hours? Withdraw assets?
No, like if let's say for example you have your assets on Starknet, right, and you want to get it to Ethereum, like the L1 finality that we are talking about, that's less than 5 hours.
It takes 5 hours.
It takes over a week if you are a optimistic rollup.
No, that's for like final, right?
Yeah.
Oh, it's a lot. But anyway, something I have not tried, so.
No. I don't think you understood again. See, if your transactions on Starknet, right,
Yeah.
they have to be validated on your layer 1, right? That takes 5 hours.
Okay.
Not like your financial transaction. Let's say you have Stark and you want to swap it and stuff. That's not what we are talking about.
No, I get what you're saying. I'm just saying that when you eventually decide to go and withdraw the assets or whatever, validate.
It doesn't take 5 hours, don't worry. I've tried. If you are talking about just cryptocurrency.
Not really crypto, whatever you're doing in terms of ID verification, and that works fine.
No, on Starknet everything works. Yeah, pre-conf is less than half a second.
And as long as you remain there, you're great. But the moment you
No. The pre-conf, okay. What is pre-conf? I said right, pre-conf is less than half a second before reaching final state. So L1 finality is when a EVM validator says this is all correct. Okay, for that EVM validator to validate those proofs, right? It's taking them 5 hours because because of the amount of proofs that's there, right? On optimistic rollups, it takes over a week to reach L1 finality because they have to go through all of the transaction details and stuff that's stored in the block space, right? So in case you have any assets that are chain between, and we're going to talk about that, that to get to L1 finality, a proper verified L1 finality, that's when it takes 5 hours. Pre-config, which means that just determining whether this will reach L1 finality or not, takes less than a second.
No, I get it. Okay.
So, moving on. Do you guys want to take a break or should we just continue?
It's up to you.
You guys can continue. I'm gonna leave soon.
Okay. We're just anyways at the end of this, where I wanted to talk about smart wallets. Okay, the concept of account abstraction, another thing that Starknet is super famous for. It's basically a wallet that allows you to sign transactions with just Touch ID or Face ID, and it executes multiple operations in a single transaction. On Starknet, every wallet is a smart wallet. Okay. And there's no, now what does EOA mean? Can anybody tell me? Correct.
Externally on?
Owned. You do, there are no externally owned accounts. And this all is built using account abstraction. Now what do we mean by account abstraction is what I'm going to get into. But for this build sprint, we are going to be using Bravos. Okay. As a wallet. So I would definitely want, if you guys have a Starknet wallet ID already, just share with me, otherwise we can create one for this.
That's what you asked in the loop.
Yeah.
So I have to basically download Xverse and I'll get one?
Yeah, you can just sign up. It's the same like how we do for
Any wallet.
Paytaka and stuff, right? It's just a wallet.
Okay, I know Xverse inside.
Yes, exactly.
So I download
Which
Xverse.
one, right?
Huh?
Bravos? You said preference is Bravos?
The only reason I said preference is Bravos because I use Bravos. That's
So
it.
Bravos is a wallet that I can download on my phone and give you a Starknet wallet ID.
Yes.
Yeah, so simple. When I looked at that question, I was like, how do I get a Starknet?
Somebody even reached out to me saying is, are you going to deduct money from my account? And I'm like, that's not what I'm asking
I
for.
think we just get the browser extension.
No, I
Yeah.
that's
You
why
can
I
even use
register
the,
on
I
the
also,
account.
yeah.
Because you entered as a compulsory, I said, how do I do this, Chavi?
No, I only, that was like a barrier to entry. I didn't want everybody to just click on register and not show up.
But I read a guy like me doesn't know what
Yeah.
I thought long and hard. Whether I could do this. I had a lot of things going on this weekend. I was like, you know what?
Exactly.
You know what? This is a good
Like the
opportunity.
whole reason I kept that registration very small, though we promoted it everywhere, was do not sign up. I do not need one more email in my email list. We have like over thousands of emails already from doing events and stuff. I do not need you to sign up.
No,
I need you only if you are going to show up.
I didn't sign up. But
You showed up.
I showed up because of so many factors. But what I'm saying is, one was to learn GK, roll up, all that stuff.
You're a little upstream of this.
Yeah.
ecosystem. I think it's catered to you, right?
So, anyways, how does complex transactions happen on general wallets is, if let's say a transaction has a step 1 and a step 2, like when a transaction requires multiple steps, right? The beauty is that you can put it in different blocks and still execute it together. Like asynchronous is what I'm talking about here. You can actually execute asynchronously multiple steps in complex interactions. I'll just move forward so I can show you what I mean is, you can actually do this. This is how it's bundled. Multiple user operations in a Starknet is bundled in a single transaction into a block, right? You don't have to like do one here, one there, one there. You can all put it all under the same transaction, multiple steps, right? What is account abstraction is? It's the decoupling of the signer and the account. What do I mean by signer and the account? Signer is the device. For example, let's say you have a smart wallet on your phone, right? Which is, for example, Browse. The device that signs the transaction and identifies the users with PQ. Okay? What I mean is, it looks like this. 1 minute. Just
So
a
when
sec.
we come with a laptop tomorrow, Windows laptop is okay with
Everything works. Like I need a Ubuntu, Windows, Mac OS.
Windows laptop.
Yeah. That's fine. In fact, there's I think there's a browser extension also for browse. Right.
I'll try.
Yeah. So it's not that this thing. Now the account is the smart contract on Starknet that holds the assets, verifies the signatures, and executes these transactions with multiple calls that we talked about, right? The multi-call on Starknet. That's what the account does. It's what account abstraction basically means is you decouple the signer from the account. Now most wallets, what they do is it's the account only that's doing everything. It's verifying it's signing the transactions. It's also identifying whether this is the owner or not, right? So that decoupling is what account abstraction is, and how it works in play is basically the signer is your device. Right, it basically invokes a transaction. Your account contract exists on Starknet, which is invoked from that transaction that goes on to the target contract, and that's how a trait is defined. And we are going to get into the programming language from tomorrow onwards, right? It's very simple, very easy, broken down to its core. You do not have to know prior programming to learn the programming language. If you know Rust, it's very good, but if you don't, I'll still be explaining the concepts. Right, so that's how it looks. We'll get into the tech side of the programming tomorrow, but just to give you a quick example of how signature verification works is programmable logic that's on the account is it enables features like single signer, multi-signer, hardware signer. In fact, social recovery and session keys can also be used as signers, and it's supported by obviously elliptic curve algorithms which are star friendly, and there's two more. One is Ethereum SECP 256K1 and SECP 256R1, which is standard.
So a whole bunch of programming would be done on Starknet using EVMs and everything from a zero knowledge perspective.
Yes.
And that's what let's see tomorrow. I was like, what use case are we going to do it in?
Oh, I will talk about the list of use cases, but just to show you the inside of your phone and how we're doing account abstraction and how it's separated, right? Let's just take the example of a general iPhone, right? They have something called as a secure enclave, which basically does the crypto key management and the random number generator. It's also where we use that hardware signer, right? Because it uses all of this, it's this dedicated processor and memory. You can use for keychains, touch ID, face ID, right? All of these, how can you use? Because of this dedicated part of your phone that's called the secret enclave. And then that shared system is basically your operating system and applications. Now we are utilizing this secure enclave of your device only to process account abstraction. It applies also for laptops. So what is this secure enclave in phones? If depending on the brand of your phone, they have their own secure enclaves. You can actually research about them. Okay? Got it.
Quick question.
Yes.
So I know you're gonna get to use case, but can one of the use cases be for like financial services?
Yeah.
Like to validate transactions and positions and stuff, because sometimes people want privacy in their transactions.
Okay.
and to prove, would that also help to, like me and him do a transaction, but we can validate to a third party that we've completed a transaction without sending them the whole transaction detail.
Exactly, that's validity proof. Yeah, we definitely can. Okay, so summary of smart wallets. Obviously, it has a better UX than regular wallets. Can do multi-call, hardware signers, or even social recovery. It enables account abstraction and account with smart. Account is a smart contract with a special interface, while the hardware is used for supporting the signing and stuff, which is the signer. Right. On Starknet, every wallet is a smart wallet. It's not a regular wallet. Okay? Are we clear? We can create a wallet
So
in...
Bravos mobile I'll install.
Yeah, I also have Bravos mobile only.
I don't have. I first heard the name. I'll do it now. Creating
Yeah.
an account with 2FA. Okay.
It basically enables 2FA because of your secure enclave only. So you create an account, you import your seed phrase, claim. So we have something called as SPOX, which is Starknet's proof of it's not knowledge, but it's I think acknowledgement or something. SPOC stands for it's like an NFT.
Okay, Nitin, I have a question. That old pink laptop of mine with that old processor, if I put Bravos, will I give it work tomorrow?
No, you don't need Bravos for coding.
I'm just saying, I'm getting a nice laptop.
Yeah, please.
The CPU is little.
It looks nice.
It looks nice.
It looks nice.
CPU is little. What is it? The CPU is non-Intel. What is Intel?
Oh, the dual core.
Not due to what was that
Celeron.
chip? Yeah, Celeron. Celeron में चलेगा ना? It's okay. The monitor doesn't work in company.
Yeah, it's not. Yeah. As long as yeah.
I'm bringing a big laptop.
You just I'll share the technological requirements today so that you can try installation on your own. Otherwise, we'll do that tomorrow morning. No, wallet you don't need only on the.
Wallet I'll put here. That I'll bring. I'll sit down.
Yeah.
Now I've got someone who's so good at pitching. Might as well enjoy. I taught all my life. Nobody taught me. Now God has decided to turn the other way. I will come tomorrow and
Yeah, it's Starknet's proof of kudos. Yeah, that's what I was like acknowledgement.
Oh, Spock.
Yeah, Spock means it's basically an NFT which stands for Starknet's proof of kudos. So everybody that's attending this workshop will get a Spock, a graduating Spock or a attendee Spock depending.
So how many times have you done this workshop before?
I've done it a couple of times in India.
Have you charged?
No.
It does power up.
Why? When people are going to sit there, learn 2 days, know this, work this out. For you.
Because it's a not-for-profit initiative.
Okay.
Yeah, okay. Anyways. And I wanted to talk about Bitcoin integration, but I'm waiting for him to come back so we can take a quick 5 minute if you guys want. I'm waiting for him to come back so I don't want to repeat. I'm parched already.
I don't know if it's our software we're using, because we tried it on Mac, Linux, we tried it on Windows, and stuff. Maybe if you take it and maybe on your system you can try it and see what it is. And,
Alright. Okay, I guess we'll I don't think I'm going home though.
no? We'll need to hear when you're.
Okay. I know I'm here a few weeks ago. Next week
I mean, it's here, it's not going anywhere. It just sucks that I'll just put it back on there.
That's so sad that
I want to get talk to you guys about this space. Let's talk.
Okay, what's up with meeting this week coming up?
Yes, please.
Me, Alwyn, and maybe Lynn. Because Lynn is our
You
boss.
have to add some of the anything between. I don't know where my life will get.
Ready?
My karma is what very Christmas. I'm not complaining. Oh, shut. It's the most important. Do I look young?
Do you know how to
We'll do somewhere. I'll have to find it from somewhere. Because we put everything away, like, this whole place was a mess.
You were
This is-
terrible.
Oh, I remember.
When you asked me whether this place is available, I only remember there was nothing available.
Yeah, you were saying? AMD?
Yeah, it's going to be about,
Did he leave?
so they're doing this thing
No.
where they're
No.
sending you the processor and the RAM.
No, yes.
You mentioned that before to me, and then you have to put it together or something like that?
No, this one is different. This is like soldered together,
Mhm.
and it's 128 gigabytes.
Oh, VRAM?
Well, it's not VRAM, it's low power DDR5,
Okay,
but because it's soldered together, the latency is very low.
okay.
So you can run an AI model on it, quantized model.
Uh-huh.
And it's basically, because it's all on like one system.
So you have 30th December.
Okay.
Now we are 20 days ahead. The flooring was being done.
Whoa.
Last I came here, me and Leo.
Damn.
So now the place was such a mess. We had to shift this, shift that. They had to put the floor. This wasn't done. He was painting.
Okay.
So you
I
are.
remember, like this, I remember that floor.
So what I'm trying to tell you is when you asked me, I had no clue where it was at. I never
Yeah,
came
yeah,
here.
yeah.
And I was so busy with life. I rarely come now. So I had no clue what to tell you. Ask Leo. He said yes, everything is ready. So first time I also came to this complete.